since we're done with complex numbers, now we need to start talking about how to solve equations. We already did linear equations. We need to talk about quadratic equations now. Okay? And there are several ways to solve quadratic equations. There are a total of 4 methods to do it. There is one that rules them all, if you want. The one ring that rules them all, which is the quadratic formula, right? We have a nice little formula that you plug in and you get a solution. But you know, it's tedious sometimes and it could be long. So there are quicker ways. That, for example, if you can factor your quadratic expression, then you can do it very quickly. Or there's also a square root method. And then why does the quadratic formula work? Because there's something more general, it's called completing the square. And the quadratic formula is just an application of completing the square. So that's the things that I need to explain to you. But before I talk about all of that, you need to know how to factor. Because factoring is not just good for quadratic equations, it's good for cubic, degree 4, whatever degree you have, as long as you can factor. Now, in general, factoring is hard. Okay. Now, when it comes to quadratic expressions, it's not that complicated. Okay. So I just want to make sure that you are comfortable with this. So in the we have like 10 minutes left. So let's just do some factoring techniques, and I'm going to be explaining some of these, and then on Thursday we just pick up on this and continue and talk about equations. Okay. So I'm not going to get into equations right now, but I do want to lay down the things that we need. And it would be nice if you review factoring by Thursday, okay? So we can go straight to the equations and you can feel more confident. Okay, so I'm going to be doing this via examples, and I'm going to be showing you some of the techniques that we use. For example, factoring the GCF, the greatest common factor. So factor the GCF. Let's make sure that we understand how to do this. So by the way, you know what this word means, factoring? When I tell you to factor something, what do I mean?
Like the opposite of distributing and making it into parentheses, like taking out the greatest common factor.
To factor something means to write something as a product, right? So for example, if I give you a number 8 and I ask you factor the number 8, you know, number 8 you can write as 5 plus 3, but is that what I'm asking you? No. What am I asking you? To write it as a product. So how do you factor the number 8? There are many ways.
You could make it 2 times 4.
But you could say 2 times 4, right? Now, if I say factor 8 completely, that means you need to factor it until you cannot factor it anymore, right? So that means this is fine, but then 4, we can keep going, right? So then the complete factorization is 2 times 2 times 2. And there's nothing more that we can do there, right? Now, I want you to understand, whenever I tell you factor, I really mean factor completely. I'm not going to be saying the word completely every single time, okay? All right, right now I just want you to factor the GCF, the greatest common factor, not completely, okay? So we understand the techniques. Okay, so 4x squared minus ax plus 16. Something like this, okay? So what do we mean by GCF? GCF is a shorthand for greatest common factor. Does anybody, do I need to write it down, or do you understand that when you read GCF what that means? It's fine? Okay, greatest common factor. So what does that mean? This is an expression, it has 3 terms. Just look at it and see if there is anything in common, any common factor. So what are the factors here? The factors here are 4 and x squared. And if you want, 4 also has 2 and 2, right? 2x squared. That's the factors here. Here we have 8 and x, and here 16. So let's see. When you have something like this, you should look at the numbers and the variables. So let's look at the variables first. Is there a common variable among all the terms? No. Among all the terms. These two, they have an x in common, but this one doesn't have x. So x is not part of the greatest common factor. Yes? So then let's go to the numbers. Is there any common factor? What is it? 4. Very good. Every number here can be written as 4 times something. Yes? And you could also say 2 times something, but 4 is the greatest. So what we do is we reverse, like your classmate said, we reverse the distributive property. Okay? So we write down the common factor here, then we open parentheses, and then inside the parentheses, you write each term divided by the common factor. Okay? So this becomes x squared minus 2x plus 4. The idea is that if you multiply this back, you have to get this. That's how you can quickly check that you did it correct. Do you understand how to do this? Okay. If you have the variables in common, then you also factor it out. Okay. So for example, how about this one? What's the GCF here?
3x.
3x, very good. So among the numbers, it's a 3, right? 6 and 9, they both share a 3. And among the variables, there are 3 x's in the first one, there's only 1 x in the second one. So what do they have in common? 1x. So 3x. So what stays inside the parentheses? It will be 2x squared minus 3. Very good. Is that clear? All right, so we wrote these expressions as a product. Okay? All right, so next, when you see stuff like this, you should be able to factor this as well. Okay? So let me make sure that you remember the ideas. So this is how to factor terms of the form x squared plus bx plus c. In other words, how to factor, this is called a trinomial. How to factor trinomials when the leading coefficient is 1. Okay? Because when the number here is not 1, we do it slightly different. Okay? But when the number here in front of here is a 1, it's a little bit easier to do. So for example, let's say x squared plus 5x plus 6. Let's do x squared minus ax plus 12. Okay, so remember, to factor something like this, the idea is that you want to write this as a product of two quantities. Okay? So typically, when you have a quadratic expression like this, it means that it's going to be factored as two binomials, the product of two things. And then at the beginning here, because we have an x squared, we better have an x and an x, right? Because there's a 1 here, then we need to have an x here and an x here, so when you multiply, you get your x squared. You understand this? So now the question is, what goes in here in the blank spaces? And when you have something like this, it's pretty easy. All you have to do is figure out two numbers whose product equals c, the last one, and the sum is the middle guy, b. Okay? So give me two numbers whose product is 6 and the sum is 5. Yes?
2 and 3.
2 and 3. So we write it. So x plus 2, x plus 3. Okay? Simple as that. So when you have something like this, all you have to do is find two numbers so that the product equals c and the sum equals b. Once you find the numbers, then you factor like so. If you cannot find such numbers, then we say the polynomial is prime. Okay? Now later, once we talk about quadratic equations, I'll give you a test to determine whether the polynomial is prime or not. Because when the numbers are small, it's easy to decide. But if you have big numbers here, how do you know that you look hard enough? Okay? How do you know that you are really, you don't find them, but maybe because you didn't look hard enough. Okay? For example, this one. And the two numbers whose product is 4 and the sum is negative 2. Can you find such numbers? Yes?
For the first one,
Yeah, so this two numbers whose product is 4 and the sum is negative 2.
you'd have to use the quadratic formula.
Two numbers, two integers. We're trying to factor this.
No.
Things that you won't be able to factor. At least over the rational, you cannot factor this. Very good. If you factor the problem, but the zeros here are irrationals.
Yeah.
They are radicals. Okay. So when I ask you to factor, I mean over the rational, like nice numbers. Okay. So this cannot be done. So try to think about it. Two numbers, the product is 4 and the sum is negative 2. If you only think about integers, you're not going to find it. Okay? So something like this we say is prime or irreducible. This cannot be factored for this unless you're willing to use irrational numbers. But then we use quadratic form. Okay, so how do we factor this one?
-6 and -2.
So -6 and -2. Okay, good. X minus 6, x minus 2. So remember, since the product has to be positive 12, that means that the two numbers have to have the same sign, right? If they have different sign, then you're gonna get a product negative, and that doesn't make sense. So either both are positive or both are negative. How do you know which one of the two is it? Well, look at the middle. The sum is supposed to be negative, so that means that the two numbers better be negative numbers. Yes? Because if you add up to positive, you get a positive. So that's why we choose negative. and then it's -6 and -2. Okay, do you understand this? All right, then for a minute. So let's play the next one, and then we're done. So how about when you have something in front of the x squared that's not a 1? Okay. How about something like this? Factor ax squared plus bx plus c with a different than 1. Okay, so here we go. So I'm going to ask you a question. Have you done this before? The thing is that there are two ways to do this. There is a short way, but it's more complicated in the sense that you need to really know what you're doing. And then there is a longer way. It's easier, but you have to write a little bit more. That's called the AC method. So there is the trial and error method, and there is the AC method. Which one do you want me to? Because I don't have time to explain both. So which one do you want me to explain right now? So AC, because AC is super easy to follow, right? The trial and error, you need to know what what you're doing. Okay, so let's do. I'm gonna do this with an example. So let's do 2x squared plus 7x plus 3. Okay, so here's what we do. So the AC method, and me here in general, so this is what we call the AC method. What we want to do is the following. So you look at the product of A times C. Okay, so first you consider the number A times C. That's a number, okay? And then what you need to do is the following. So find two numbers. So find two numbers such that the product equals A times C and the sum equals B. So it's very similar to what we did above. So look at the first times the last one, that will give you something. Then think about two numbers whose product is A times C and the sum is the middle one. Okay, that's the first step. Once you find that step, then the next thing that you're gonna do is, so that's step number one. Step number two is then write. Okay, so let's actually do it here. So here, A times C equals 6, right? 2 times 3. So I need two numbers whose product equals 6 and the sum equals 7. What are these numbers? 6 and 1. Good. Now, once you have these numbers, what's the next thing? Well, because 6 plus 1 is 7, you're going to take the middle guy and you're going to write it as the sum of 6 plus 1. Okay? So now we're going to take the middle guy and we write it as 6x plus x. Okay? And then what we do is we factor by grouping. So I didn't mention factoring by grouping above, but what does it mean to factor by grouping? There is not a common factor among everybody here, but if you make groups, you can find a common factor. So when you take it out, another common factor shows up, and then you can factor. So for example, here, you can group the first, and you can always do this. You don't need to rearrange terms here. So you can always group the first two and the last two. Let's see, what's the common factor in the first group? What's the GCF in the first group? 2x. And what do we get? X plus 3. And then plus, in the second group, well, there's really, put another plus. Then this is just x plus 3, right? There is really nothing to factor out. I'm just going to put in parentheses to express the fact. And if you want, you can think of this as having a times 1. Okay? Why? Because now, notice that we have two terms, and they both have an x plus 3 in common. So you can now factor that as a common factor. And so what remains when you take out x plus 3? 2x plus 1. So a 2x from here and a 1 from here. Yes? So this is called AC method. So that's the first step. And the second step is write bx as the sum of these numbers. And then the last one is, after you do this, then factor by group.